It is Mr. Dave with the Ray Kitty Creation Workshop, and you are watching the Ray Kitty Science Project. Thanks for joining us here again. We've got some fun science, but not some at-home science this time. The experiment that we're going to be doing, I want to say demonstration. I use the word experiment. Experiment is when you don't know what's going to happen. A demonstration is when you know what should happen. So this demonstration that we're going to be doing is you can do at home if you have somebody with a little bit of knowledge about some of these different materials, but this is not one that you would have the students hand them these materials and go, because we do have some materials that are hazardous, okay? I want to kind of point out a little bit of a difference between hazard and danger, okay? I used the word danger earlier. I'm using the word hazard now, okay? There's a reason for that. I want to say that these are hazardous materials, okay? And that means if you handle them improperly, it can have negative effects, okay? Something that's dangerous, even if you're handling it properly, can have some poor effects, okay? So this is not dangerous, but it is hazardous, meaning you want to be careful with these materials. So again, just as a heads up out the gate, this is not really one that you would do just hand the kids these materials, and I'll show you why, okay? First, some of the materials that we are going to be using are hazardous in and of themselves. We are going to be using sodium hydroxide, okay? Sodium hydroxide is also known as lye, okay? And it can cause chemical burns. You don't want to inhale it. You don't want to eat it. So this is something that you would want to keep away from the kids. If you were doing parts of this, with them as a demonstration, make sure that this is set in a place where a kid doesn't accidentally grab this. This one is a little bit more hazardous. Now, I want to do this even though it doesn't have all the hands-on that we usually have. If you caught our last episode, that one was all hands-on stuff, and we were doing kind of the same thing, but now we're doing it on a larger scale. Our last one, we were using electrolysis to generate hydrogen, okay? Now, again, terminology, I'm saying generate. You can't make hydrogen, okay? We hear that we have these hydrogen generation stations and things like that. The word generate, they use pretty often. It is accepted. You will see it in scientific articles, but to generate hydrogen is impossible. You can release hydrogen, okay? Hydrogen is already everywhere, okay? There's more hydrogen in the universe than there is anything else, but you have to release it from things if you're going to be using it. So I will be saying make, I will be saying generate, and both of those words are okay to use, but you have to know that that hydrogen atom is actually already there. We're just releasing it, okay? So I will say make, I will say generate. If you say make and generate, you're not wrong, okay? But the proper term would be to release, okay? So we have our sodium hydroxide, okay? Again, if you're doing this one at home, this is an adults only, and make sure that you are taking some precautions. The precautions that I'm going to be using today is I will be wearing gloves, okay? And I will be wearing safety glasses, because in addition to having a hazardous material, we're also going to have fire, okay? Now, these ones here, these kind of demonstrations are fun every once in a while to just get a little bit bigger science, even if it is something that isn't as hands-on. It's fun to kind of draw people in if you are, comfortable with these materials. I have a fire extinguisher on hand. Even if you're not seeing it on the camera, it will be right here on the table. If you watch some of our previous episodes, I'll show, I showed you about the lab safety with a fire extinguisher, but we do have that one on hand. It will be over here. If you can't see it, I can still see it, okay? Now, we're not going to be generating or causing huge fires, but anytime you have fire of any sort, you want to make sure that you've taken precautions for that, okay? So we have a fire extinguisher. We have sodium hydroxide. We have a little apparatus for making fire, like a little lighter here, okay? There you go. So we have our little lighter. Our lighter is going to be what is causing our hydrogen to poop, okay? To give us a little pop of hydrogen. Now, when you saw, if you watched our last episode, if you didn't, go back and watch our last episode, but we were electroplating materials and it caused these little bitty hydrogen bubbles. Now that was doing it with electricity and an electrolyte solution. This time we're going to do it with just chemicals, okay? So we're going to use these chemicals to release that hydrogen. There's a lot of different ways to release hydrogen because, as I said, it's everywhere, okay? So in addition to our sodium hydroxide, I have water. Okay, this is regular water in this beaker here. Lab safety, just because something is clear doesn't mean you can drink it. And when we add our solution, or when we add our sodium hydroxide to this, it may end up being clear. You don't want to drink that. Okay, but this is just normal water. Now, normally when you're seeing something like this, you'll see that they'll put that rubber stopper in there or something like that. The way I'm going to do this one today is I am going to stop this and release our gas via this little tube, but I'm going to do it with the tape, just because we are going to have some pressure that's building there, and I don't want my cork to go flying up, hit one of these lights in here, and then go knocking everything all crazy, okay? So I am going to be using tape to stop this one today, just because if the pressure builds up in excess of what can come through this little tube, the tape will just open up and release that, okay? Now, that being said, we're continuing with the potential hazards. This is a very exothermic reaction, meaning it will generate heat. This beaker is going to get hot. Okay, now it's not going to get hot enough to burn you. If you're doing this one, you'll still be able to handle it with your hands. You can put it on a table. It's not going to hurt the table, nothing like that. But it is exothermic, so don't be surprised if you grab it and it's, whoo, that's warm, okay? It's probably like hot pizza hot, okay? So you can still touch it, but don't put it in your mouth, okay? Now, we have this little tube here. We're going to be using that to catch our hydrogen that we produce, and we're going to be putting it into this solution here. Now, this solution is extremely scientific bubble solution. Bubble solution. Now, the bubble solution, the way to make the best bubble solution, if you're making it at home, you've probably made bubbles with dish soap before. Everybody uses dish soap. Put some dish soap in there, stir it around a little bit, and you get this. But if you want to be a little sciencey about it and actually make much, much, much stronger bubbles, you are going to use some of this. This is glycerin, okay? Glycerin you can purchase over in, like with the skin products at the store, and that glycerin will make for a very strong bubble, okay? Now, this solution here I made today, I should have made it last night. If you let it set overnight, you're going to get the best bubbles. We're going to get the medium best bubbles because I didn't give it time to slake or to set overnight. But the glycerin, the stoichiometry, you may see on the internet, oh, I use exactly this much. And I don't know why they talk in that voice, but pour some in. The dish soap, pour some more in, right? You want about twice as much water as you have dish soap, a little over twice as much. And the glycerin, you just want to go for a while, okay? And really, you don't have to worry about that stoichiometry. It's a bubble, okay? So the stoichiometry, again, is the ratio of things in chemistry or in cooking, okay? So I have my bubble solution here. I brought this just to see if I can make a bubble, make sure my bubble solution is working. I'm going to dip this in there, see if we can get a bubble. Yeah, that's a pretty good bubble solution. Yeah, we can make a pretty decent bubble with that. I probably could have kept going, but I ran out of air because I talk so much. So we know that you can use this bubble solution just for bubble fun, okay? Now, what we're going to be doing with these bubbles, that bubble there was filled with a very particular type of material called Stinky Dave breath. Okay, I filled that bubble with Stinky Dave breath, just the air from my lungs. That's disgusting, but that's what that bubble was filled with. Now, when we're filling these bubbles here, we're going to be filling them with hydrogen. Now, a thing about hydrogen is that hydrogen is flammable, okay? Meaning it can light on fire very easily. So you're going to want to take those precautions. Now, before I begin messing with my sodium hydroxide, I am going to put on my gloves. And yes, I have purple ones because they're Ray Kitty gloves. So I'm going to put on my purple gloves. And then I will handle those materials. So our bubble solution here, we're just going to scooch out of the way just a little bit. I'm going to put this here. Notice this isn't a glass beaker. Remember how we talked about that exothermic reaction? If you have this in plastic, it can melt the plastic, and yeah, it can be a little scary there. So you want to make sure that this is in a glass beaker, or you can do it in just a little glass jar if you have a way of closing the lid. Now, when I say closing the lid, do not seal the lid on this, okay? You do not want to seal the lid. If you have this thing sealed, it can very, very easily, that pressure can cause some problems. So you don't want to seal this in there. And that's why I'm using the tape, and that's why we have our little vent that is going to be venting through the through that little hose there. So I put some in there. Remember, as I said, the stoichiometry on this one is not too important. In the water, this is already a little bit of that exothermic. You may notice a little bit of heat, but there's not much until we get to the next part of the reaction, okay? So I just want to kind of stir my solution up a little bit there, and we're looking pretty good. I'm going to get this out of the way, okay? Now, the reason I have my gloves on is because I don't want that to get on my skin. There's a little bit of it here on the table. I don't want to end up touching that. If you do touch it, you don't have to run away and you know, like, I'm melting, you know, nothing like that. But you do want to wash your hands, okay? Because if it does stay on there, you can get a chemical burn. So you want to just be careful of that. Now, things like this tablecloth, this glass, none of that is going to be affected by it. But I wouldn't want to have any metal out here, and I'll show you why in just a second. So we have our tube that we're going to use to actually generate the bubbles, and we have our tape that we're going to use to seal it up. So what I'm going to do is I'm going to take this tape, I'm going to put it over the top, I'm going to poke a little bitty hole, and I'm going to put my tube in there. Now the tube will not go into our liquid. Okay, that's very important. You don't want that tube to go all the way into the liquid. We just want it to be up here because we want to capture the gas, not the liquid. Okay, you don't want the liquid to come shooting out of here. You only want the gas to come out of here. So when we do it, hydrogen, just like in a big old Zeppelin or Zephyr or the Hindenburg, hydrogen floats. And so as it is rising, it is going to come to the top of this, and that's going to be mostly what we're pushing out of there. We will have a little bit of atmosphere from inside that jar, but mostly hydrogen, okay? Now, our next kind of part of the experiment is this right here, aluminum foil, okay? When I say aluminum foil, I always want to sing the Weird Al song, but I'm not going to do it. But this is aluminum foil, and you're going to take your aluminum foil and you're going to just make some little balls with it. And what it's going to do is that solution that we have here is actually going to dissolve this aluminum foil. And when it does, that's going to release that hydrogen. When it releases the hydrogen, that gas is going to take up more space than we have in the bottle, so it's actually going to be pushing that gas out through our little hose there. Now I have another thing of water here, and what you're going to see me do is when I'm going to ignite the bubbles in this one, I'll move my hose over to this one here, just so we don't have our hose in the same one and then end up having a torch. Okay, so our sodium hydroxide, when I put this aluminum in, this aluminum actually has a coating on it that kind of helps keep it food safe, so that if you have in particular salted ham. If you wrapped salted ham in untreated aluminum, a lot of this same reaction will happen on the outside of your ham, and you could get sick. And so that's why they coat food-grade aluminum foil. So I have my little things here. I don't have any salted ham, but it is getting close to dinner time, and I am thinking about that now. But I'm going to make a decent number of these. Now, when this happens, I may have a little bit of bubbling up coming on, but I mentioned the coating on this. The coating means that it's not going to happen right away. It's going to take a few seconds before it kicks in. So I have my little aluminum foil balls here, and that should be plenty. I'll do one more. And then I'm going to get my tape ready so that when I put that foil in there, I can begin sealing it up right away. Now, another part as far as the being careful with things, the gas that's coming off of here is not just hydrogen. You do have a little bit of a noxious gas that's coming off. Not enough to make you sick or anything like that unless you just sat there breathing it, but you may smell it and it may smell strong. So that is something you just want to be aware of, okay? Now, the way I'm going to do it is I'm going to put my foil in there. I'm going to put my tape over the top to seal it. Once I've sealed it, I'll poke a little hole, I'll put my hose in there, and then we'll start generating that hydrogen, okay? So I'm going to make sure that everything is going to fit first, do kind of a dry run. We should be good there. And I'm going to put my foil in. And again, the stoichiometry is not ridiculously important, but we do want to, I'll probably end up adding some more foil as we go there. You can see not a lot is happening yet. So I'll see if I want to add a little bit more of that sodium. It's beginning now. That reaction is starting. You can see those bubbles starting to form around our little foil there. So I'm going to go ahead and prep this part. If I have to put a little bit more of that sodium in there, I'll put it in there. But see how I've got this hose in here? This is going to capture those gases, and it is going to make bubbles over here. So I'm going to see, I may put just a little bit more of our sodium in there, because I'm getting some of those bubbles, but not quite enough. So I'm going to put a little more sodium in just so it happens a little bit quicker. Again, be careful when you're messing with this sodium. Make sure you always have gloves on, because you don't want this to sit on your hands. If it stays on your hands for a little bit, like I say, it's not really going to be the end of the world, but you don't want it to stay on there very long. Okay? So let's see. Now we're getting a little bit of that reaction. I'm going to put a little more tape here just so I don't have any of that gas escaping, because we want to use all of that gas to make our bubbles. There it goes. Okay. So I've got a little bit of a gap right here. Now my tape is not very pretty. Don't make fun of my tape. There you go. So we'll see if we are getting any of that gas yet. And that will start forming bubbles in this one here in just a second. Now this is a pretty large beaker, so we'll see. Let me mix that up just a tad. And after all my talking about this being a demonstration, watch it end up being an experiment. Okay, let's see. Oh, it's starting. We're getting a little bit of fizzing. If you look in there, if you can see in there, you can see how that aluminum foil is starting to bubble, bubble, bubble. And I will make sure that I am capturing it all. So I'm going to put a little bit more tape around our little hose here, just to make sure we're catching all of those little bubbles. And we should start getting some into our into our bowl over here. Now this is making for an awesome slow point. Let's see. Let me give it just a minute. I may want to put a little more foil in there. Let me see. Now, it's tricky waiting with the patience, and because it is happening, our reaction is going on there. Time lapse? Yeah, maybe. Let me see. Okay. Because I'm not getting too much of it right now. So give me a second. Okay, so I'm going to take this tape off. I'm going to put a little bit more in there and see how we do. After all my talking about the stoichiometry, I may want a little bit more in there to speed up that reaction just a tad so that it makes for better television. So let me see. You can see I've got a little bit of that vapor. We are putting off that gas, but we're just not putting it off fast enough to make very many bubbles yet. So I'm going to put a little bit more in there, speed up this reaction just a tad. You can see that vapor there. So it is happening, but we want it to happen a little faster. So we're going to put a little more in here. And that will speed it up just a tad. And hopefully we can get those bubbles in there. Oh, I can hear it going now. So let's see. Get our hose in there. And try one more. Seal this up just a little bit better here. And see if we can get those bubbles. Not a single bubble. Okay, let's see. So I know that I am producing the gas because we can see that happening there. Let's try just going again. I'm going to re-tape my little seal here and see how that works. If I can get my tape off, because now I'm trying to be quick about it. There we go. And then let's try this one more time. Get this one out of here and give me a little hole here. And see if we can capture some of those bubbles now. Welp. There we go. Okay, so now we're capturing those bubbles. We had a little bit of a difficult time getting a seal on there. So you may have noticed a little short cut there. But we had a little bit of hard time sealing our bubbles in there or catching our gas. Now, these bubbles here that we're capturing are actually hydrogen bubbles. Okay, so we have all of that in there, and that they are actually filled with hydrogen. Now, the hydrogen is, as I said, very flammable. So when we take these bubbles here, okay, I've got these bubbles. I'm going to keep this sealed here. I'm going to pull over my other little container. And we're going to see if we can get those bubbles to ignite. Okay, so our hydrogen bubbles, it's a fun game. Let's see. Yep, there you go. So I might have to call it. Let's see. We may have gotten one episode done today instead of two. I don't know that this is going to do it. I don't know what the issue is, but it is not doing it.
That's totally fine, yeah, if you need it.
Yeah. we may, I don't want to take up a whole bunch of guys' time, and then I don't want to have a whole bunch of dead air there. I don't know why, and air, yeah, because, but let me see.
Yeah, if you get to where we could do what we did that one time
Where we had the pause in there? Yeah.
The two pieces together, and we can just time lapse.
Okay, yeah, let me see if I can get that going.
But, I mean, if not, we can film it.
If not, yeah.
But, I mean, we still got enough time.
Okay. Yeah, I appreciate your patience on that one. I don't know what the, we've done this one all week long, Charlotte and I. Okay, so let me see. Well, I haven't had one totally bomb yet, and this is like episode 20 or something like that, so we should be okay. This is my first total bomb. Now, I don't want to say bomb when I'm messing with hydrogen. Yeah, I don't know. Yeah, it is just not doing it, guys. So it did go from a demonstration to an experiment. Let me try one more time here. It's definitely happening. It's just a matter of capturing the happening. What do you think, Charlotte? Okay. Give this one more shot, and then, like I say, I may have to call it. Okay. So if you want to roll again, we're getting it now. Okay, so I had to kind of mess with my seal a little bit there, but now we have some of these bubbles forming. These bubbles are hydrogen, okay? And hydrogen is flammable. So we want to be careful to make sure when we are igniting this, that we are igniting this somewhere other than where our hydrogen is being produced. But if you watch here, our hydrogen is, woohoo! Yeah, those hydrogen bubbles are very flammable. And so the hydrogen that we're producing here that is being released from our from that aluminum and the sodium hydroxide is what is giving us these nice pretty bubbles. And these nice pretty bubbles are now filled with hydrogen. When we pop the bubbles, then the oxygen is able to get in there with that hydrogen, and that gives us that nice little pop on there. So this one over here, I've got some bubbles over here. I'm going to switch back to this solution. And then I will see about these little bubbles here. You can, if you can catch them and get them on your hand, whoo-hoo, then you've got those little hydrogen bubbles that you can pop there. Okay? So this hydrogen that we're generating, as I said, remember to say we're releasing. So we're releasing this hydrogen, and when we release this hydrogen, we're forcing it down this little tube into our bubble solution, and that bubble solution is what is giving us those nice little bubbles that we have there. And that hydrogen, because in and of itself it's not going to ignite, but when you pop that bubble, then it allows that oxygen in there with that hydrogen, and that hydrogen will go poof. Okay, so what we had here was our hydrogen generation. Okay, and remember, I'm using the term generation, but we're actually just releasing the hydrogen. So the hydrogen was already in here. You can see it's still being produced in our little beaker here. Now, this is something, you may see a little bit of vapor coming off the top there, Again, safety-wise, if you're doing this one at home, you're not going to want to be breathing a lot of that vapor, but if it's in the area, just use common sense with anything about like if you were spray painting something, okay? The material will be in the air, so you'll want to be careful with that, but you don't have to like run and hide or set up fans or anything like that. So we're producing hydrogen bubbles by extracting the hydrogen from our aluminum foil and our sodium hydroxide. Okay, so this one here, I appreciate the wonderful team, all the camera guys and editors and things like that for cutting this up while I had a little bit of difficulty with my seal. But this one here is, as I said, just for adults. So make sure that you are, practicing safe handling with all of these. And because you are using fire and things, make sure you have a way that you can put that out. Okay, so I am Mr. Dave. Thank you for watching. And remember, science shows you matter.